So this is the algebra review, and we're going to start with this first problem, which involves numbers here. And so we want to do 3 divided by the quantity 6/7 minus 4/9. And so to do this, the first thing you need to do is find a common denominator on the bottom here. So it's the same thing. We're just going to leave the 3 alone, 3 divided by. And finding a common denominator is a very simple thing, just 7 here and a 9 there. So what you're going to do is you put a 9 here. If you put a 9 here, you'll put a 9 up there. So we have 6 times 9 divided by 7 times 9 minus, and over here by the 9 you're going to put a times 7, so we'll have 7 times 9, and on top you have to put a 7 too, so 7 times 4. So now remember, this right here is still 6/7, and this right here is still 4/9, but now you'll notice that the denominators are the same, so they have a common denominator. And so what we can do is we can bring the two fractions together, but first maybe I'll do these multiplications. So 6 times 9 is 54. And then divided by 7 times 9, which is 63. Then we're going to take off 7 times 4, which is 28. And then we have 63. And so that's going to be equal to 3 divided by. And on the bottom you have 54 of these things minus 28 of these things. So that leaves you with, I believe, 26 of these things. So notice if you add 28 and 26, you do get 54, so that's right. Divided by 63. And so then that's equal to, now remember, when you divide by a fraction, the rule is you multiply by its reciprocal. So this is 3 times the reciprocal of 26 over 3. You simply just flip it, so you get 63 over 26. So remember, when you divide by a fraction, so here I'm dividing by a fraction, you simply multiply by its reciprocal. And then when you do multiplication, remember this is 3 divided by 1, so you just multiply the numerators and you multiply the denominators. So 3 times 63 is actually 189, and on the bottom we have 26. Students always have a difficult time working with fractions. And it's because they're a little abstract, but if you think about it, it kind of makes sense. It's sort of like if you take 1/3 and you take away 1/4, or let's say we add, because addition is easier than subtraction, and you add 1/4, you simply just can't add the 1s and add the 4s. I mean, it should be obvious from an example like this, 1/2 plus 1/2. If you could just add the 1s and add the 2s, you would get 2/4, which again is 1/2. So 1/2 plus 1/2, which is a whole, is still a half. You can't do that. Right? So what you have to do here, and the reason for this, is that the denominators are not the same. So 1/3 and 1/4 are really not the same thing. It's like you have one of these and one of those. And so you can't add them until you make them the same. You can think of this as like sort of adding a whole orange to like 5 slices of an orange. How much orange do you have? Well, you just can't add 1 in the 5 slices and say you have 6 what? They're not the same thing. So first you have to turn the orange into slices, and then you can add them together. So the idea is 1/3 and 1/4 are not the same thing. So somehow you have to turn them into the same thing, and the way we do this is we find that common denominator. So we take 1/3 here and we multiply the bottom by 4 and the top by 4. And over here I'll multiply the bottom by 3 and the top by 3. So that preserves the two fractions. So here you have 4/12 plus 3/12. And so you have 4/12 plus 3/12. And if you say this is like 4 things plus 3 things, and they're exactly the same thing, is 7 things. And so that's one sort of explanation as to why we need to always find the common denominator when working with fractions. In essence, they're not the same thing. It's sort of like taking a half a cup of flour plus a third a cup of flour and saying how many cups of flour do you have? Well, you have to convert them in the same sort of cups, and then you can add them together to get that many cups of flour. Let's look at the next one. So on the next one, we're going to work with exponents here, and so we're going to perform this operation. So now this is 16, and maybe we should rewrite this because it's kind of hard to see, but this is 16 to the -3/2. So this is sort of an exercise in technical reading in the sense that you have to understand, what does it mean when you have a negative in the exponent? What does it mean when you have a fractional exponent and the numerator is 3 versus when the denominator is 2? Right? So a negative in the exponent means always put it in the bottom. So this is just 1 over 16 to the 3/2. And then when I think about the fractional part in this of this exponent, I think, oh, the 3 is the good thing and the 2 is the bad thing. And the meaning of this is, let's write down just sort of a general formula. Like if you have x to the m over n, n is a bad thing in the sense that it's the root. So roots are always, in some sense, bad because you can't do them, right? You cannot take the square root of 2 without a calculator, square root of 3. Now you can do the square root of 4, which is 2, but square root of 5, you're out of luck. Square root of 6, you're out of luck. And so on. There are some you can do. The nice perfect squares, like square root of 9 is 3, and so on. But most of the square roots you can't do. Same with cube roots, fourth roots, and fifth roots. So that's why I say, oh, the denominator here is bad, and m is good because it's the power, x to the m. Right, so numerators are good, so it's a nice power. Denominators are bad, so it's the root. So when I look at this, I'm actually going to read it and say, hey, that 2 in the denominator means take the square root of this thing, and a 3 means to cube it. So it doesn't matter the order, but one's usually easier to apply first. So I'm going to take the 2, which means take the square root of 16, and I can take the square root of 16 because the square root of 16 is 4, so that's actually 1 over 4 cubed. And then I'll cube 4. So the cube of 4 is 4 times 4 times 4, which is 64. And so that's my answer for this one. The next one, we want to simplify this expression. You'll notice we've done away with numbers, and we've introduced variables, right, x and y. And again, it is an exercise in sort of reading the exponent or looking at the exponent and doing what it says. So this exponent is negative, right? In the last problem, the exponent was also negative. It meant put it in the bottom. So whatever's in top, you put in the bottom. And you could guess whatever's in the bottom, you're going to move to the top. So this is going to be x squared on top, y to the negative 1/2. And notice how my x's and y's look very different from each other. That's very important, especially later on when we do more complicated problems. And then the top is going to go to the bottom. So I'll have 5 on the bottom now, x to the 3/2, and then y cubed. Now I just took care of the negative part of the exponent, so I still have all this squared. Right, so when I have all this stuff squared, and when you look at this, you should see basically 5 things. So if you look at this, here's 1 thing, here's 2 things, here's 3 things, 4 things, 5 things. What you want to do is you want to square each of these things. So one way to say this is that the square goes through multiplication and division, or the exponent goes through multiplication and division. So you're going to square this, square this, square this, square this, and square this. And the way we square it is when working with the exponents, you multiply exponents. Sometimes these rules I've internalized, but there are times when I do forget them, especially if I didn't use them enough. So what you can do is like, okay, well, do you add exponents or do you multiply exponents? So if you think of x squared and you cube it, right, so this is if I add, this would be x to the 5th, whereas if I multiply, this would be x to the 6th. So which one is it? I mean, you can simply test it because you know when you cube something, right, x squared cubed is actually x squared times x squared times x squared, which is actually x to the 6th. So you're not going to add exponents, you are going to multiply. And so the same thing's going to happen here. You just simply multiply exponents. And so x squared to the square is x to the 4th. Y to the, if you have negative 1/2 times 2, right, so you're multiplying exponents again, so the 2's are going to cancel, and you get negative 1, divided by 5 squared, which is 25. And then 3/2, if you multiply it by 2, the 2's again are going to cancel, and you got x cubed. And then you have y cubed, and you're going to square, so then you're going to take 3 times 2, and you get y to the 6. And so we're almost done here. The last step is to cancel out what they have in common. So you have cube down here, and you have the 4th up here. So 3 of the x's are going to cancel on top along with the bottom. So you have 1x on top, divided by, and you have 25. Now the negative means put it in the bottom, so you have y to the 6th. If you put an extra y down there, you're going to get y to the 7th. And so that's how I simplify this expression. The next one we want to express as a power of x. So the idea is we should be able to write this whole expression right here as a single power of x. So x to some power. So let's rewrite this. So you have x to the 5th. And then remember, 3 is the root, which is the bad thing. and 2 is the quote power, which is the good thing. So this is actually x to the 2 divided by 3. Right? Remember, dividing by 3 in the exponent means take the cube root, and 2 means take the square. And so what we have now is we're going to, instead of multiplying exponents like we did last time, you actually add exponents. And again, you can do silly examples like if I have x times x squared, I know that's equal to x cubed. Oh, because that's a 1, right? So what do you do with the exponents? You don't multiply them because 1 times 2 would be 2. You add them. So x to a number times x to a number, you simply add the numbers. So you have x to the 5 plus 2/3. And I have to figure out what 5 plus 2/3 is, so I have to add fractions. So 5 plus 2/3. Remember, a 5 is simply 5 over 1, so I'm going to find a common denominator. So I'll take 5 times 3 divided by 3 plus 2 times 5 divided by 3 times, divided by 3, my bad. Divided by 2/3. So now the denominators are the same, so I simply took a 1 and turned it 3 by multiplying top and bottom. And so this is 15 over 3 plus 2/3. Remember, this number is still 5. 15 divided by 3 is 5. So you haven't changed the number, you just changed the way it looks. So if you have 15/3 plus 2/3, and your brain will automatically do this, right? 15/3 plus 2/3 is 17/3. It's like 15 apples plus 2 apples is 17 apples. And so then my final answer would be that this is equal to x to the 17 divided by 3. All right, so then working with polynomials now. All right, so we worked with numbers, we worked with exponents. Now we want to work with polynomials. This one's one I find students typically stumble upon. They're fine with multiplying this out if I have x plus 2 times x plus 2. So when you do x plus 2 quantity squared, you guys have no problem. But when I do cube, things tend to get a little bit messy. And so the reason why this stuff gets a little bit messy is sometimes just the way you're thinking about it. And so the best way to think about this is when you're multiplying, you're actually using what's called the distributive property. And the idea is you're going to distribute the x through each of these. And we'll do one at a time. So it's like take x times this and x times this. You know, sometimes we call this FOIL. And so x times x is x squared. And x times 2 is 2x, so plus 2x. And then we'll take 2 times x and then 2 times 2, so we get plus another 2x. And then plus 2 times 2, which is 4. So basically, you're just distributing the 2 through now. And then this is still all times x plus 2. We'll save that one for the next step. And so we'll simplify by simply bringing together like terms. So 2x plus 2x is 4x plus 4. And then you have times x plus 2. Now what's nice about the procedure we just did, when we say we just distribute the x through here and distribute the 2 through here, is we can do it exactly the same way on this problem. So what we'll do is we'll distribute the x squared through, so we'll do x squared times this, and do x squared times that. So what you're going to get is x cubed plus 2x squared. And then we'll take the 4x times x and the 4x times 2, so we'll distribute the 4x through, so plus 4x squared plus 8x. And then finally, we will take the 4 and distribute it through, so 4x times 2x. So that's plus, so 4x plus 4 times 2, which is 8. And we simply add like terms. So here you say equals, and so there's just one x cubed term. There's no other x cubed, so I just simply write down x cubed. There are a couple x squared terms, so there's 2x squared and 4x squared. And so 2 of these plus 4 of these is 6 of these, so plus 6x squared. And then we have a couple x terms, so 8x and 4x. So 8 of these plus 4 of these is 12 of these, so 12 plus 12x. And finally plus 8. So sometimes I'll tell you guys, just use the arrows
And if you use the arrows correctly, there's no problem multiplying this out. And if you do x plus 2 cubed, you can do x plus 2 quantity, x plus 2 to the 4th power, x plus 2 to the 5th power, and so on. Okay, factoring. So this is sort of going the other way. So instead of multiplying out, what you want to do is you want to pull out what they have in common. And the way this works is first I typically look at the numbers. And I guess first you have to see that there's only two things here. So you have this thing minus that thing. Okay, that's the first thing. But inside each of these things, you have a couple things, right? So you have a 3, you have an x plus 1, x minus 5, you have a 9 here, x plus 1, and x minus 5. And what you want to do is you want to pull out what they have in common. So I look at the numbers first. So for the 3 and the 9, I say I'm going to pull out a 3 because they have a 3 in common. And then I see this thing, x plus 1 squared and x plus 1. Now, x plus 1 is just raised to the 1. We usually don't write that. But they have that in common, so you want to pull out it. And what you want to pull out is always the lowest power. So if you have a square and a 1 power, the smallest power is a 1. So you pull out x plus 1 to the 1. And then x minus 5, they also have this in common because it's there and there. And so we want to pull out a cube, not a fourth, because a cube is smaller than a fourth. So we'll pull out x minus 5 quantity cubed. And we play this game. It's like something goes here minus something goes there. And these somethings, the idea is this times that is this thing above. And this times that is this thing right here. All right, so let's erase this. And so the question becomes, what goes right here so that when you multiply this by this thing, you get exactly that back. And so you notice they have a 3, so you don't need a 3. This has an x plus 1, but you want an x plus 1 squared. So what we're going to need to do here is put an x plus 1. And then this has an x minus 5 quantity cubed. This has an x minus 5 quantity cubed. And so we're done. This times this is that. And then you look at the next term, and you say, okay, so what goes here times this thing gives us that thing. So you have a 3, but you want a 9, so you need to put the number 3 here. So 3 times 3 is now 9. You want an x plus 1. You have an x plus 1, so no more x plus 1s are needed. And then here you have an x minus 5 to the 4th. Here you have an x minus 5 cubed, so you need one more x minus 5. So now this times that is exactly that. And what we can do is we can simplify on the inside. So you have x plus 1 minus, so 3x, and then minus 3 times negative 5. Remember, a negative times negative is a positive, so it's a plus 15. And so what you really have is 1 plus 15, which is 16, minus 2x. And then this has something in common too. All right, so right here, 16 and a 2 have a 2 in common. So this is really 2 times something minus something. And so here you're going to need an 8, because 8 times 2 is 16. And here you're going to need an x, because x times 2 is 2x. So my final answer is this times this times this, all times that. So I'll have 3 times 3, which 3 times 2, sorry, which is 6. So put the numbers together. I have an x plus 1, an x minus 5, quantity cubed. Let's make that 3 better. And then I also have this 8 minus x left over on the end. All right, so this times this times this times this will give us this above. So factoring is actually a very important part of this class, especially when we're solving equations later on this semester. What we'll do is we'll learn how to take derivatives, and we'll end up setting those derivatives equal to 0. And to solve those equations, sometimes you'll have to factor the things out that they have in common, so it's easy to see what the zeros actually are. All right, so the next thing we want to talk about is solving equations. And what we're going to do here is we're going to solve different types of equations. We're going to do a linear equation, a quadratic equation, a rational equation, an exponential equation, a logarithmic equation, and a trigonometric equation. So it's basically 6 equations. And these are the equations that you need to be somewhat familiar with on how to solve them. The first one's a linear equation. So if you didn't know that, take note of it now. It's a linear equation. The reason it's linear is because x appears, and it's only to the first power. So that's really x to the 1, and that's really x to the 1.
We normally don't write that, but that's what makes it linear. You're not dividing, right? It's just x to the first power and then numbers. What makes this linear equation difficult, and you should understand that this one's a little bit difficult because if I gave you this one, 2x plus 5 equals 7, you'd say I could simply solve that by moving over to the 5, moving over to the 2, and have my solution for x. But this one, what makes it difficult is that divided by 2. And so I always tell you guys when you're solving equations, what you want to say is, what's the issue? And if you can see the issue, which is the divided by 2, then you just want to undo your issue. And the way we undo this issue by dividing by 2 is we'll multiply the whole thing by 2. So we'll multiply the x by 2, the 6 by 2, the 14 by 2, and the x over 2 by 2. And what will happen then is you get 2x here plus 12 is equal to 28 minus, and now here's where the problem goes away. When you multiply x over 2 by 2, it becomes an x. And so this equation is a lot easier to solve because it doesn't involve fractions. Right? That's what made this one a bit difficult. So you undo or get rid of the issue, and then typically you'll be able to solve it. So what I'll do is I guess I can move over the 12. I'll do this one step at a time. And then until you get really good at these, you should just do one step at a time. That way you don't make any mistakes. And so I'll get 2x is equal to, and then 28 minus 12 is what? Not 14, but 16. All right, so 16, if you add 12, you get 28. And then minus x. And then we'll add x to both sides, because the idea is to get x alone. And so now we have all the x stuff to one side, so we have 3 x's is equal to 16. And then to get rid of the 3, since we're multiplying, we just do the opposite. Notice we are multiplying there. So it's divide by 3, and we get our answer, x is equal to 16 over 3. Now what's nice about solving equations is you can always check your work by plugging back in. So you're not supposed to use a calculator to solve it, but you could use your calculator to check it. So the idea would be take 16 over 3 and plug it in for x here and add 6, and you'll get out a number. And then take 14 minus and put 16 over 3 in here and divide by 2, and you'll get out another number. Those two numbers should be the same if you solved it correctly. Let's look at the next equation. So the next equation, we call this a quadratic equation. So this one's a quadratic. And what makes it quadratic is this 2 right here. So if you have something with an x squared and an x and a number, it's typically called a quadratic equation. And to solve a quadratic equation, there are a number of ways to do this, but this one, the idea is you're supposed to factor it. Not all quadratic equations can be factored, but the one I'm giving you here can be. And that's the easiest way to solve a quadratic equation. Basically, there are 3 ways you can factor, use a quadratic formula, or complete the square. And we'll talk a little bit about each of these in one of the lectures coming up. All right, so how do you factor? So it's x plus or minus something times x plus or minus something, and you have 0 on the right, so equals 0. And the somethings come from the 21. So the first thing I want to do is I want to look at the 21, and I think, 21, what are 2 factors of 21? And hopefully your brain says 7 and 3, because that's what it should say. If it doesn't, you need to work a little bit more on your times tables and get them down. So when you see 21, your brain immediately says 7 and 3. And then I ask the question, is there any way to add or subtract a 7 and 3 and get a negative 4? Because it's minus 4 there. My brain says, yeah, you can take minus 7 and you can add 3. And that will give you negative 4. And so this is my guess. You can check it by multiplying out. So if you take x times x, you get x squared. If you take x times 3, you get plus 3x. If you take negative 7 times x, you get minus 7x. And then negative 7 times positive 3, you get negative 21. And so that's actually x squared minus, because you have 3 of these, take away 7 of these, so minus 4 of these, and minus 21. So it checks, so I did it right. So I know that this is me thinking, really, just checking in my head. So I know this is true. And what happens is you have this times that is equal to 0. So I know if you have 2 things and you multiply them together and get 0, one of those things has to be 0. So I know that either this is 0 or that is 0, because there are 2 different things I'm multiplying together and getting back 0. So I know that x minus 7 is equal to 0, or I have x plus 3 equal to 0. And I can solve these 2 equations now. And so this is x equals 7. I add 7 to both sides. That's one answer. And x equals negative 3 because I subtract 3 from both sides. So x is equal to negative 3. And again, you can check your work by plugging in 7 and squaring it, taking away 4 times 7 minus 21. It better give you back 0 if you did it right. And we can do the same thing with this negative 3. We can plug it in, square it, take away 4 times negative 3 minus 21, and we should get back 0. So that's a quadratic equation. The next problem is a rational equation. So this is a rational equation. And when you look at a rational equation, the idea of a rational equation is you have x on top and also x is on the bottom. Right? So it's like a polynomial on top divided by a polynomial on bottom in terms of x. We call this a rational equation. And the trick to solving these is you want to get rid of what you're dividing by. So you want to get rid of the 2 and rid of the 2x minus 16. Now, this one you may want to rewrite before you try to figure out what you're going to multiply both sides by to what we say clear the denominators. You may want to rewrite the bottom here. You want to pull out that 2 right there. So that's 2 times something minus something. And this is an x because 2 times x is 2x. And then minus, and this is an 8 because 2 times 8 is 16. So then it's really clear that if you multiply by everything by the number 2, and then also by x minus 8, it's going to clear the denominators, which means get rid of the denominator. So 1 times this, so you're going to have 2x minus 8 on the left, equal to, and now when you take this times 2 times x minus 8, the 2's are going to cancel, so you just get x times x minus 8. And then minus, now this one's really nice because when you take this times that, these things completely cancel, and so you're just left with the x on top. Alright, so this is definitely better than what we started with, and what you want to do now is you want to multiply through by the 2 here, so 2 times this and 2 times that, so you get 2x minus 16. The fancy word for that is you want to distribute the 2 through, so everybody gets a 2. That's called the distributive property. It's like if I distribute $1 to each student in the class, each student gets $1, so now each symbol or each expression, let's say, gets a 2. And now each expression here gets an x, so you have x times x, which is x squared, minus x times 8, so 8x. Then you have minus x on the end. And so what we can do is we can combine like terms. So this is equal to x squared minus 9x, because you have minus 8 of these, minus 1 of these. And then let's bring over the 2x. So let's take away 2x from both sides. And so we're going to get negative 16 is equal to x squared minus 11x. And then we'll bring over the 16. Now you may be asking yourself, well, why is he doing all this? I thought he wanted to get x by itself. Well, it turns out if you have x squared, you cannot get x by itself. What you need to do is bring all the stuff over to one side, and you'll see you have a quadratic equation. So on the left-hand side, I'll have 0, because negative 16 plus 16 is 0. And then I'll have x squared minus 11x plus 16. So how do we solve this quadratic equation? Now we could try to factor it, but when we try to factor this thing, you're going to see that it can't be factored nicely. So you would do x plus or minus something, x plus or minus something. The something would come from the 16. So when I think of 16, the first thing I think of is 8 times 2. And there's no way to add or subtract 8 and 2 and get 11 out. And then the same thing, I go back and say, okay, now 8 and 2 didn't work, so how about 2 other factors of 16? And so it'd be 4 and 4. And there's no way to combine 4s and get out this, negative 11. So what this means is you can't factor it. So you have to find another way to solve this quadratic equation. So that other way that you should be somewhat familiar with is called using the quadratic formula. So the quadratic formula looks like this: x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Where you have this 0 equal to ax squared plus bx plus c. So a, b, and c are these nice coefficients. So in our problem here, a is equal to 1 because there's a 1 in front of x squared. B is not positive 11 but negative 11, and c is 16. And so what you want to do is you simply plug in the numbers. So you have this is equal to negative b, so negative and negative is a positive, so you should have positive 11, plus or minus the square root of negative 11 quantity squared, so you get 121 here, minus 4 times, and then you have AC, so A is 1 times 16, so times 16, all divided by 2. That should be a 2a down there. It's all divided by 2a. So all divided by 2 times 1, which is 2. And so this is equal to, then, you have 11 plus or minus the square root, and then you want to take 121 minus 4 times 16, which will be, well, here, let's do it. So 121 minus, then 4 times 16, that's a 40 plus a 24. So what is that, 64? All divided by 2. And so that's equal to 11 plus or minus, and this answer is not going to be very nice. So 121 minus 64. All right, so it's not quite 60, right? Because if you add 60 to 64, you get 124, so it's 3 less. So that's 57. And then all divided by 2. And so you get 2 answers, the plus answer and the minus answer, and that's it. You can't simplify this one any more than is given. So that's how you solve this one. What you want to notice, though, is that to solve a rational equation, you converted it into a quadratic equation. To solve the quadratic equation, you actually convert it into 2 linear equations. So each time you're solving one of these equations, you're sort of converting it back to sort of one that we've done before, so they each sort of build on each other. So number 10 is an exponential, solving an exponential equation. So we call this an exponential equation. The reason for this is because x is in the exponent. Right? So it's called an exponential equation. So let me rewrite this. And the way you work or solve exponential equations is you use their inverses, which are logarithmic equations, or logarithms. So like if I want to bring down, the problem is that x is in the exponent. So what you want to do is unlock the exponent. And to do that, what you're going to do is you're going to ln both sides. You apply what's called a natural logarithm to both sides. And the logarithm has a property that if you ln something to a power, the power can come down in front. So it unlocks exponential stuff. So that's sort of the real power of logarithms. It can allow you to access whatever's in the exponent. So the 4x will come down in front, so you get 4x ln of 3 equal to 2x minus 1. Let's put parentheses around, so it's the whole thing, times ln of 5. Okay. Then from here, you want to solve for x, so we need to unlock the x stuff inside here, so the left side stays the same, so you have 4x ln of 3 equal to, now you're going to multiply through by the ln of 5, so ln of 5 times 2x, so you have 2x ln of 5 minus 1 times ln of 5, so times ln of 5. And I'm doing this to unlock the x stuff inside here, so then I can move it over, so I'll take away 2x ln of 5 from both sides. So again, I'm trying to get all the x stuff by itself, if I can. And so what I have on the, let's rewrite this over here. What I have on the left is I have 4x ln of 3 minus 2x ln of 5. And on the right, I have this equal to minus ln of 5. And so this is typically where a student will get stuck on these because they don't know how to combine this x stuff and this x stuff. And the reason for this is because of the way that you think about adding x's and your sort of dependence on the numbers. It's sort of like if I gave you 5x minus 3, if I gave you, let's do that like this. If I give you 4x minus 2x, you have no problem saying that's equal to 2x because you know exactly what 4 of these and 2 of these mean. But if you replace them with symbols like, oh, so suppose I have ax minus bx, well, how many x's are those? Well, you don't know what a and b are. You don't have a sort of a context for them, a feeling for them. But you can still simplify this. You can still say how many x's because they have x in common. So the trick here is to realize you can actually and you can do this here too, you can actually just pull out the x. Like right here, you could pull out the x and say this is x times 4 minus 2 of these. So you know 4 minus 2 is 2, but if you didn't, you could say it's this many x's. Same thing here, you could say this is x, and then you have a minus b. Right, so it's a minus b x's. So the same thing can happen here. You can pull out the x here, pull out the x there, so you have x times something minus something. And so it's 4 ln of 3 minus 2 ln of 5, and that's equal to, on the right, still ln of 5. And so this times x, to solve for x, since you're multiplying, you just divide. So we're just going to divide out by that nice big expression. I don't know how many things it is. It's, 4 ln of 3 minus 2 ln of 5 things. We'll divide both sides by it, and we'll get our answer. So 4 ln of 3 minus 2 ln of 5. And so my final answer, x is equal to negative ln of 5 divided by 4 ln of 3 minus 2 ln of 5. And again, since you're solving an equation, you can test if you did it right by taking this number, which you can use your calculator to crunch, and then plugging it in for x here. You get some number here, then plug in, again, whatever number you found here, and for x, you'll get another number on the right. These two numbers should then agree. So that's an exponential equation. And then after an exponential equations, we usually do logarithmic equations. So this is a logarithmic equation. And they always involve logs. So you have ln, this is a natural log, so that's why it's called a logarithmic equation. Again, to solve this, you're going to use properties of logarithms. And so there are a couple properties that you should hopefully be familiar with. And so 1, 2, and 3. One is if you add logs, so you have log of m plus log of n, you multiply on the inside, so log of m times n. And then if you subtract, you don't multiply, you divide. So if you have, and we should probably use ln, so let's use ln of m minus ln of n. And so this is usually ln if you divide on the inside, so m divided by n. And if you raise something to a power, so ln of m to the p, the power can come down in front. And we've used this property already, so p times ln of m. So these are some properties of logarithms you should be familiar with. So when I'm looking at to solve this equation, the idea is to get log of something on the left equal to log of something on the right. So here I know this 2. I could put that up in the exponent. So what I really have here is log of x plus 9 minus ln of x plus 3 quantity squared is equal to ln of 1 over x. So that's something. It's a little bit better than this. And it's a little bit better because now I can deal with that subtraction, because I know if I have ln of something minus ln of something else, I can divide those things inside. So this is actually ln of x plus 9 divided by x plus 3, let's make that 3 better, 3 squared, is equal to ln of 1 over x. And so when you have ln of this equal to ln of that, we know the things on the inside have to be exactly the same. And the reason for this is because ln is a function that's said to be 1 to 1. So it allows us to conclude that x plus 9 divided by x plus 3 quantity squared is equal to 1 over x, which is now a rational equation, which we sort of worked with before. And so when you're working with rational equations, the way you simplify it is you want to get rid of the denominator, so we'll multiply both sides by x, because that'll eliminate that denominator. And we'll multiply both sides by x plus 3 quantity squared, because that'll clear that denominator. So we're clearing the denominator. So what will we have left over? So let's see. When you take this times that, the x plus 3 squareds cancel, so you'll have x plus 9 on the left, all times x. Right, so this times this is that. And then equal to, on the right, you have this times this, so the x's cancel, and you're left with x plus 3 quantity squared, which is definitely nicer than this. And this is a little bit nicer than that, I'd say. But what we can do now is we can simply multiply through by the x. You have x squared plus 9x which is equal to, square this out. So remember that x plus 3 squared isn't just x squared and 3 squared. You'll always have that middle term because it means x plus 3 times x plus 3. So when you FOIL that thing out, you're going to get x squared, but you'll always have this middle term, a 3x and a 3x. So you get 6x, and then plus the 9. And so then what you want to do is try to get all the x stuff by itself, and notice it's really actually pretty nice because if you take away x squared from both sides, they're going to cancel. So it's not really a quadratic equation because as soon as you subtract x squared from both sides, they go away. And so it's really a linear equation now, so move over the 6x. And so what do we get here? We get 3x is equal to 9. And so since you're multiplying by 3, to solve this you're going to divide by 3, so you divide both sides by 3, so x is going to be equal to the number 3. And you can check this answer by simply, again, plugging in back here and using your calculator to check it. The last type of equation we're going to do is a trigonometric equation. So this is a trigonometric equation. These are definitely a bit tricky. Right? Trigonometric functions in general are a bit tricky because there's a lot to it. Right? There's a lot to this type of, in essence, a technology. And so what you want to do to solve this type of equation is first you see, oh, they have a sign of x in common. So you can actually break this into two problems if you factor out the sign of x. So what I'll do is I'll factor out the sign of x. So I factor out the sign of x, and I have something plus something equal to 0. And then for the somethings, it's like something goes here times this is that, so that's going to be a 1. And then something goes here times this is going to be that, so it's going to be a 2 and a cosine of 2x. And what this gives me is two things. This times that is equal to 0. Right? If it's equal to 0, then I know either this is 0 or that is 0. So that's a nice observation. And so I know either sine of x is equal to 0, or I have 1 plus 2 cosine of 2x equal to 0. And so my one equation, when I factored it, it turns out to be actually solvable in terms of two equations. So I want to solve this one and that one. All right, so let's work with the easier one first. So this is actually probably the easier one. So sine of x equal to 0. Here's how we would do this. All right, so if sine of x is equal to 0, I want to find all the answers between 0 and 2 pi. And what I know is that all students take calculus, and this is really a nice sort of user interface for the unit circle. And what it means, all students take calculus, is if you give me an angle in this quadrant, the sine, cosine, and tan of that angle will be positive. But in this quadrant, if you give me an angle over here, in the second quadrant, only the sine of that angle will be positive. The cosine and the tan of that angle will be negative. If you give me an angle down here, the tan will be positive of that angle, but the sine and cosine will be negative. And of course, if you give me an angle in the fourth quadrant, the cosine of that angle will be positive, but the sine and tan will be negative. So what that tells me is at least a 0 isn't actually much, because if it's 0, it's neither positive nor negative. So what do I know? I know that I can pick basically any two you want. So what I would probably pick is I'd probably pick this one and that one. Right, so the angle is going to lie in one of those two quadrants. It can lie in either of those two quadrants. And for 0, you have to look at the table. And so there's a table that I have memorized. So if you give me 0, and I have, let's say, pi over 6, 30 degrees. These are radians, pi over 4, and then pi over 3, which is 60 degrees, and pi over 2, which is 90 degrees. I know this table, and I'm going to do it for each of these. So the cosine of an angle, let's make the angle theta. So we can do cosine of theta and sine of theta. So why don't we do it? I'm going to do sine of theta first, I think. So sine of theta, so this is for theta, and then we'll do cosine of theta right below it, so cosine of theta. What I have to remember is one of these. I have to remember the sine of 0 is actually 0. And so it works like this: square root of 0, square root of 1, square root of 2, square root of 3, and then square root of 4. And then these are all divided by 2. So divided by 2, divided by 2, divided by 2, divided by 2, divided by 2.
And then the sign of these angles is basically the same, but you write it backwards. So root 4, root 3, root 2, root 1, root 0. And again, they're all divided by 2. So divided by 2, divided by 2, divided by 2, divided by 2, divided by 2. And so what I need to do is I need to look up the angle that gives me back 0, and of course that's right here. And so that corresponds to the angle 0. And so I immediately know then my reference angle is 0 here, and then it's also over here, right? Reference angle 0. And that tells me the answer. So the answer is actually pretty easy to write down. So I look at my picture and say, well, the first answer is 0. And then if you go pi radians over here, you get another answer. Pi, you get another answer. Pi, you get another answer. Pi, you get another answer. So plus pi n, where n is an element of the integers. All right, so remember the integers z, if you're not familiar with z. So we write z, which is a set of integers, so it's a set of all numbers, and we start at 0 here and write 1, 2, 3. So all these nice, what we might call whole numbers or natural numbers here, including 0, and then also the negatives of them. So -1, -2, -3. All right. And in the end, you probably would just write x is equal to pi n. You don't need the 0 plus, because 0 plus anything is the anything. So n is z. And n is an element of z. N is an element of z. So that's my final answer. So it says it's 0, pi, 2 pi, 3 pi, 4 pi, and also the negatives. So negative pi, negative 2 pi, and negatives mean just go the other way. Instead of going counterclockwise, now you go clockwise. So negative pi, negative 2 pi, negative 3 pi, negative 4 pi, and so on. This one's a little bit more standard. So let's solve this for cosine of 2x, and then we can actually figure out the angle here. So what we'll do is we'll take away 1 from both sides. Let's draw a line too also right here, so we can separate the problem. So we'll take away 1 from both sides, and we get 2 cosine of 2x is equal to -1. And then we'll divide both sides by 2, so you get cosine of 2x is equal to -1/2. Right, so this is the same type of problem as we did before. You had the sine of some angle equals some number. Now we have the cosine of some angle equals some other number. And so how are we going to solve this? And it's the same steps. So we're going to say all students take calculus. This one's a little bit easier to apply because it's not 0. Remember, 0 is not really positive or negative. It doesn't have a sign to it. But this is obviously negative. So I know immediately that I'm either in this quadrant or that quadrant. So those are the two I care about. I do not care about these. The angle can't be in the first or the fourth quadrant, because if it was, the cosine of that angle would be positive, and obviously it's negative. All right, so I have some angle here, and then some other angle down here. So when you take the cosine of it, you get -1/2 out. And so to figure out what that angle would be, I can find the reference angle by looking for 1/2. So here's the cosine, here's 1/2, and it corresponds to pi over 3. So then again, I immediately know that this angle, this reference angle, right here is pi over 3. And let's make that 3 better. And then this angle right here is also pi over 3. And now to find the actual angle, so you have to remember actual angle is always measured from the x-axis. So this is the first one right here. So this angle right here. To find that angle, there are a couple of ways to do this. You can count off in terms of pi over 3 and say, hey, there's 3 pi over 3's in pi, and so this must be 2 pi over 3. Or what I typically like to do is say, hey, if you go all the way pi, you get right here, and then you want to go back pi over 3. So the blue angles actually go all the way to pi, so all the way halfway around, and then go back the reference angle, so go back pi over 3. So take away pi over 3. It's a little bit longer sometimes when you do it this way, but you'll never make a mistake in some sense. And here again, you're subtracting fractions. We've been talking about fractions a lot here, so it's really important that you get comfortable with them. So here I'm subtracting fractions, and so what I'll do is I'll say, hey, that
pi is actually 3 pi over 3 minus pi over 3. I'll find a common denominator. And so that's actually 3 pi over 3 minus pi over 3 is 2 pi over 3. And so my first answer will be 2x is equal to, because remember it's not x, it's 2x is equal to 2 pi over 3. And then on this one, you don't add pi, because if you add pi, you don't get to another answer. Pi gives you in this quadrant. But if you add 2 pi, you get back to right where you started. So if you can add any multiple of 2 pi, so 2 pi n, and again, n is an integer. The multiple can be 1, 2, 3, 4, or it could be negative. So it could be negative 1, negative 2, negative 3, negative 4, so on. And then my second answer, let's do this one in red. My second answer, so my second angle, looks like this. It goes all the way around past pi and an additional pi over 3. So the way I find it is I take pi and I go in extra, so plus pi over 3. And then I do what it says. I find a common denominator, so I put a 3 here and a 3 down here. And so 3 of these plus 1 of these is 4 of these, so 4 pi over 3. So my second answer would be 2x is equal to, so again, it's 2x is the angle, not x. 2x is equal to 4 pi over 3 plus 2 pi n. N is an integer. So again, n can be 1, 2, 3, 4, 0, negative 1, negative 2, negative 3, negative 4, and so on, dot, dot, dot. Right, they keep on going, dot, 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 to the left and to the right. And so I'm almost done. I want to solve this for x. So I will divide both of these, everything, both sides here, by 2, by 2. Divide both sides here by 2, and by 2. And when you do that, the 2's cancel on the left, and you get x equal to. And when you divide 2 pi over 3 by 2, you're going to multiply actually the 3 and the 2 there, so you're going to get 2 pi over 6. And then here the 2's are going to cancel. Remember, the 2 gets to each of these because you're adding. This is divided by 2 plus that's also divided by 2, so you get plus pi n. N is an integer. That's important. Over on this side, you're going to get what? You're going to get x on the left is equal to, when you divide by 2, again, you could think about this like multiplying by the reciprocal. The reciprocal of 2 is 1/2. So you're multiplying this by a half and this by half, so that you're going to get 4 pi over 6. And then plus pi n, and again, n is an integer. And we can simplify these a little bit more. So this one on the left, x will be equal to, the 2's will cancel, and you get pi over 3 plus pi n. N is an integer. And the one on the right, x equals, and then here again, 2's will also cancel, so you get 2 pi over 3 plus pi n, and n is an integer. Okay. Students like to sort of gloss over this problem, but these are really important, and they come back up again and again and again. They're not terribly difficult to do once you get it down. So if you work and practice on these, it will really help you later on in the calculus, different calculus courses.